So in this video, we are going to look at inverse of an exponential function. And here I start with the exponential function. And to graph it, I got some values in the domain from -3 to 3. I plug them into the equation, and this is what I got for y. I graphed it. And what I got looks like an exponential growth function. And then I went ahead and graphed the function g of x. I graphed the function g of x, and you can see the domain I used and the y values I got. And from what you see these are convenient values I got where I will be able to evaluate the logarithm without using a calculator. Like 2 raised to what power gives me -1/8, gives me 1/8, so I got -1/3. For 2 raised to what power gives me 4, I got -2. 2 raised to what power gives me 1, and then 2 raised to what power gives me 8, I got 3. So I was able to evaluate the logarithm because I got some convenient values, and they just happen to be from the range here. So now, looking at the two functions, I can see there is a relationship. There is a relationship, and I can see the transformation is a reflection over the line y is equals to x, and you can see it right here. That's a reflection. So, and the conclusion I can make here is that f of x and g of x are inverse functions. They are inverse functions. So here we are looking at logarithms, and we are going to look at two types of logarithms you are going to encounter. One is called the common logarithm, and this is a logarithm with base 10, and this is the way we denoted logarithm to base 10, or simply logarithm. And the natural logarithm, which has a base e, and you're going to see logarithm to base e denoted commonly as ln. So here is the common logarithm, here is a natural logarithm, and here you're going to use a calculator to evaluate the logarithm, and you're going to load your answer to the nearest thousands, 3 decimal places. So here, the first one, when I use my calculator, this is what I get: -0.07, and actually more accurately 71. And then the next one, natural log, this is 3.09. Those are values I just got from the calculator, and you can confirm with your calculator. So here we are looking at inverse functions, and we are going to use what we know, the definition of an inverse function. Here we already know that f of x is equals to 2 raised to x, and I know that g of x is equals to logarithm to base 2 of x. And I'm going to do some work down here, just some review. Remember, if I do f of g of x is the same as taking the g function, and instead of x, I'm going to plug in, logarithm to base 2 of x, which is the gx function. And since these two are inverses, I should get x. Now, in the same way, I'm going to do g of f of x. And I'm going to take the g function, which is logarithm to base 2, and instead of x, I'm going to replace x with 2x. And because they are inverses, which I confirmed on the previous slide, I should get x in both cases. So something I want you to note here, which is going to make your work easy. I want you to note this base 2 and 2, so you end up with an x. This is 2 and this is 2, you add with an x. Remember logarithm? Remember this is the base. Okay, so when I go here to these examples, see when I have e, remember this is the same as logarithm to base e of 4. See when I see this 4 right here, this e, and I see this one, I know the answer is going to be just 4. So here the answer is 4. So let's go to the next one. Remember this is logarithm to base 10. Whenever if you don't see the 10, remember it's a common logarithm. And then 10 raised to 5. And in the same way, let me just highlight. Remember this is a logarithm, base 10, 10. So the answer is simply going to be, the answer is going to be simply 5. And for the next one, I have logarithm to base 5. But since I don't have 5, but I also know that this is 5 squared, but I already had an x. So what do I get here? I see, again, I root the base, so my answer is going to be 2x. Is going to be my answer. So here we are told to find the inverse of the function, and I'm going to start by interchanging x and y, switching x and y, so that becomes logarithm to base 5 of y, and then I'm going to write it as an exponent, so 5 raised to x is equals to y, so that will be the inverse. So that's the inverse of the function, and actually we can write it as equals to 5x. That's another way of writing it. Now here we have this example here, and again I'm going to start by switching x and y. Then I'm going to, this is x, let me write this one as logarithm to base e, because this will make our work easier here. So now I'm just going to rewrite it as an exponent. E raised to x is equals to e raised to x is going to be equal to y minus 1. I just wrote it as an exponent. And then to get y, I add 1 to both sides, and this is going to be e raised to x plus 1. And that's the answer. The next one here, I'm going to start the same way I started the other one. So this is x, and this is 2y plus 3 minus 4. Remember the goal is to isolate y. So I subtract 4 from both sides. So I get 2y plus 3. And then I still want to isolate y, but the only way I can isolate it is by introducing logarithm to base 2. So I'm going to write logarithm to base 2. Whatever I do on one side, I have to do it on the other side. Is equals to logarithm to base 2, and then 2y plus 3. And using the properties of exponents, I know all this is going to be gone, and I'll be left with y plus 3. So So this is going to be logarithm to base 2 x minus 4 is equals to y plus 3. And finally, I can subtract y from both sides. So I get logarithm to base 2 x minus 4 and then minus 3. And I can write using the inverse notation. And that's the answer.